4.7c, let's talk about the inverse graph of sine and cosine. So continuing with our inverse functions, let's do the arc sine, right? So let's say y equals the arc sine of x. Sine of x, and this is our x, this is our y. Our x values for sine of x is basically, when we talk about our x value, what when we put in a sine, what can it equal? Well, sine cannot get anything larger than 1, right? So we start off at 1 and we end up, so let's say this is 1/2 and this is -1/2 and this is -1. It doesn't get any bigger than this. Say this is -3/2, just for sake. So it doesn't get any bigger than 1, doesn't get any smaller than -1. So it stops in between our domain is between -1 and 1. And here, my y values, then let's call this one 90 degrees or pi over 2, and this one pi. And within our unit circle, it falls between, because once we get into like anything bigger than 180 degrees, it will become negative degrees. So let's put in our negative values here. So our negative values being negative pi over 2 and a negative pi. It's going to start off our sine of x. Right? When we start off with -1, so let's say this is -1 here. Actually, to make it look better, well, it starts off at -1 and negative pi over 2. Right? At -1, sine of x is negative pi over 2, or negative 200 or 270 degrees. At 0, sine of x is 0, and then at 1, sine of x is pi over 2. So it kind of curves like that, kind of ish. Oh, okay, I see what I did there. The units down aren't the same as the units going up. So let me try to change this a little bit. Okay, so then this should be here. There, it should have been more symmetric. So this is our sine of x. Let's do cosine of x, or the arc cosine of x. Our cosine of x, if you think about it, it starts at 1, or at 1, our cosine of x is 0. 0 degrees, right? At 0 degrees, our cosine of x is 1. At pi over 2, at 90 degrees, our cosine of x is 0. So it should be here. And then we want to go and then up to at pi, our pi, right, at 180 degrees, our cosine of x is 1. And then it kind of curves like this. And those are our two different sine of x and cosine of x graphs, the inverses of them. Let's try some other examples with inverse functions too. Let's say we are given the inverse function. They want us to find the inverse function of this, and they give us a picture. We are given a triangle now, and here's theta, and this is x plus 1, and this is 6. Well, isn't that just opposite over adjacent? So here, our answer is x plus 1 over 6. And we can't simplify it anymore, so that's just our answer. Let's try a different one. Let's say we had, move this up, we had a x squared minus 9, and this is our theta here. And we have a x minus 3, and we want to find this theta, the inverse sign of that. Well, to find theta, right, when our theta, here our theta equals this, right, the theta would equal the inverse tangent of that. So our theta is the inverse tangent of that, of all that. Here, to find our theta, wouldn't it be the inverse sine of, let's say, x minus 3 over x squared minus 9? We can simplify this a little bit. I know that x minus 3 and x squared minus 9, well, that's a difference of 2 squares. So we have x plus 3, x minus 3. These two simplify each other out. So this is also, theta is the inverse sine of 1 over x plus 3 simplified. And that would be our answer right there. Now let's say we are given, and they want us to find the algebraic expression of equivalent. So let's say we have secant of the arctangent of 5x. Okay, and they want us to find the equivalent of secant of the arctangent of x. Well, let's draw a triangle. Always help to try to draw a triangle to try to figure that out. The arctangent of 5x. Well, this means our tangent is opposite, which is 5x, and I'm going to make this 1. I got to find the hypotenuse. So that is 5x squared plus 1 squared equals c squared for Pythagorean. So this is 25x squared plus 1 equals c squared. C is then the square root of all that, 25x squared plus 1. Right? So this is the square root of 25x squared plus 1, just like so. And we want the secant of that. Well, isn't the secant the adjacent, which is 1? No, it's the hypotenuse divided by adjacent. So that's the secant would be the 25x squared plus 1 divided by 1, which is this in itself. So our answer is that. Let's try another example. Let's say we want to find the cosine of the arcsine x minus h over r. We're not given a lot, but always draw a triangle. That's what I always do. Our sine is x minus h. Our sine is opposite, so this is x minus h. By hypotenuse, this is r. So then, if I use Pythagorean theorem, x minus h squared plus, I'm going to call this b squared equals r squared. I'm just gonna solve for b. b then, b squared must equal r squared minus x minus h squared, right? And now I just got to find the square root of it, right? So b must equal the square root of r squared minus x minus h squared. It doesn't look pretty, but that's what it is. So this, I can't simplify it anymore. There's no tricks that I can think of to use. So that's just what it is. Now I want to know the cosine of that. Well, the cosine is just this divided by that. So the cosine is square root of r squared minus x minus h squared divided by r. And that is that. I can't simplify it more. There's no math tricks I can do. That is just my answer. It doesn't look nice, but it's the answer.